The topic of this video is graphing piecewise-defined functions. This is a continuation of the previous video. Alright, in our previous video, we created the graph of this piecewise-defined function, and that graph is shown here. Now we're going to move on to the remaining parts of the problem, which are identify if the graph is continuous or not, and then state the domain and the range. Alright, so let's start with whether it's continuous. Can we draw this entire curve without picking up our marker? And let me be clear when I say the curve. The curve I'm referring to is this ray right here from the open dot all the way to the arrow, as well as this closed dot, as well as the part of the parabola that goes from this open dot and then towards up to the right and away, all the way up to infinity. Those three pieces. Can we draw all three of those pieces without picking up our marker? The answer is no. And for that reason, this graph is not continuous. Okay, let's talk about domain and range. Now, usually when we do domain and range, we just look at the graph and we get our domain. And that can be done even with this graph, but there's a far, far easier way to find the domain of a piecewise defined function. And that would be to look at all of the possible values of x listed in the if condition. I'd like you to notice that these are all increasing values of x. We've got the ones that are less than 0, which are the smallest, 0 itself, which is in the middle, and the ones that are bigger than 0, which are the largest. So as we travel down our piecewise defined function, the values of x are getting bigger and bigger and bigger. These are the only values of x that we are allowed to use, and therefore they're the only values of x that belong in our domain. Now, let's see if we can talk about what values of x we're using. We're using all the values that are less than 0, all the values that are greater than 0, and 0 itself. Well, if you think about it, that's every number in the world. Every number in the world, every real number in the world is either more than 0, less than 0, or 0 itself. And for that reason, our domain is negative infinity, comma, infinity. Okay, now when it comes to the range, there's nowhere up here for us to get any useful information. We are forced to look to picture. And we'll do so in the way that we've done in previous videos. So for example, find the point that is lowest, the one that is furthest down. That would be this open dot. Find the one that is highest, the one that is furthest up. Well, that would be a tie between this arrowhead and this arrowhead. But considering we know that the very next thing we're going to do is to try to connect the lowest to the highest, we're going to choose this one over here. Now, can we connect this open dot to the arrowhead by moving along our line or curve without picking up our marker? The answer is yes. So that's going to tell me that my range is going to go from the y value of this open dot, which is 0, all the way to the y value of this arrow. Now this arrow is pointing two directions, up and right. Which one do we care about for range? Up. How do we write up forever? Positive infinity. So our range is going to be from 0 to infinity. Infinity and negative infinity always get the parenthesis, and 0 in this case gets a parenthesis because of the open dot on the graph. All right, so with that, we've now completed this problem. We created its graph, we determined if it was continuous, and we found the domain and range.